If you've got a bit more time to dedicate to the summary of the fresque, here is an example of how you can do the synthesis. First, we can see that everything starts with human activities and that they can be grouped into the 4 categories. These are the drivers. For 3 of the 4 categories, fossil fuel usage is the main contributing factor to greenhouse gas emissions. Industry represents 40% of greenhouse gas emissions in the world, primarily through the use of coal. Building usage represents 20% of the world's greenhouse gas emissions, mainly through burning natural gas for heating, while transportation represents 15% of greenhouse gas emissions, primarily from oil. When we burn fossil fuels, CO2 gets released. Agriculture represents 25% of greenhouse gas emissions globally. Part of the emissions are from CO2 emissions due to deforestation. And remember that agriculture is the main driver of deforestation, responsible for 80%. When we deforest, we often burn the trees and so release the CO2 contained within. Agriculture is also responsible for greenhouse gas emissions that are more potent than CO2. Over a 100-year period, methane has a warming effect that is 25 to 30 times higher than CO2. Nitrous oxide has a warming effect that is around 300 times higher than CO2. So that's our drivers. Where does the CO2 go? The CO2 is partly absorbed by natural carbon sinks. That's the ocean, forests and vegetation through photosynthesis. The rest of the CO2 stays in the atmosphere. The increased concentration of CO2, together with other greenhouse gases, creates the additional greenhouse effect. The key word here is additional, because the greenhouse effect is natural and a good thing. It gives us an average global temperature of about 15 degrees Celsius, making life on Earth possible. Without this natural greenhouse effect, the average temperature on Earth would be a very cold -18 degrees Celsius. Think of it like a blanket wrapped round the Earth, trapping some of the sun's energy, keeping us warm, and life has flourished. The additional greenhouse effect from the different human activities is like adding an additional man-made blanket around the world and throwing us out of balance. Let's have a quick look at radiative forcing and aerosols. Radiative forcing is a measure of the difference between the energy that arrives every second on Earth and the energy that leaves. Aerosols is a pollution or a particulate matter in the air that is released during incomplete combustion of fossil fuels, mostly from transport and some industrial processes. On the one hand, the additional greenhouse effect contributes positively to radiative forcing, and thus has a warming effect, while on the other hand, aerosols contribute negatively and have a cooling effect, which sounds like a good thing, but aerosols are the smog that hang over our cities. It's the PM 2.5, the air pollution, and they are very bad for human health. Overall, the radiative forcing is net positive at 2.8 watts per square metre, i.e. we are trapping more of the sun's energy than before pre-industrial levels. This means that more energy is absorbed by the Earth, and the energy budget explains where that additional energy is being distributed. Primarily, it's going into the oceans, which then of course increases the temperature of ocean waters. The energy also melts different types of ice, glaciers on our mountains, ice caps which are on Antarctica and Greenland, and finally, sea ice. The energy will also increase the temperature of the air, which has increased by 1.2 degrees Celsius since 1850. The IPCC presents different scenarios for rising temperatures from an additional 1.5 degrees Celsius to 5 degrees Celsius by 2100. You can see those pathways on many of the graphs, all depending on just how much greenhouse gas we release into the atmosphere in the coming years. So now we've covered the drivers and the mechanisms of the science, the first part of the story. Now let's look at the consequences. We start to see how these phenomena affect extreme climate events, such as cyclones, river and coastal flooding, droughts, heat waves, and so on, making these phenomena more strong and more frequent. More specifically, the rise in water and air temperatures will lead to disruption of the water cycle. This can lead to more rain, which causes river flooding, or less rain, which can lead to droughts. Droughts also exacerbate river flooding because when the ground is very dry, more water runs off. Another impact of climate change is sea level rise. Sea level rise is due to the melting of ice caps and glaciers, which add mass to the oceans. Rising water temperature because warmer water takes up more space. Sea level rise will lead to coastal flooding in the long term. And in the short term, cyclones can also lead to coastal flooding. Rising air temperature will also lead to more heat waves, which in turn can lead to forest fires. Drought also exacerbates forest fires. Freshwater resources are affected by changes in rainfall, but also by the disappearance of glaciers that regulate the flow of rivers. All these extreme climate phenomena lead to decreases in agricultural yield. So will problems in freshwater resources and disruption to terrestrial biodiversity, particularly pollinators. Speaking of biodiversity, let's go back to the ocean cards briefly. The CO2 that is being absorbed by the ocean leads to ocean acidification, which in turn impacts organisms with a calcium-based shell. These are at the bottom of the food chain, and along with rising water temperatures, these factors negatively impact marine biodiversity. We see the negative impacts of these phenomena on humanity in the final 4 cards: armed conflict, climate refugees, hunger, and human health problems. Remember that many people rely on food from their ocean as their primary source of protein, and shifting vectors of disease add to human health issues. Many people will be on the move across borders, but we also need to consider internal migration as well. While certain areas are on the front line to the worst of these impacts, and many are experiencing them now, no one is immune to these consequences. This is a lot to hold, but it doesn't stop there. There is one further aspect that we need to consider: positive feedback loops, the consequences of an action that can lead to more of that action happening. Let's look at 3 such examples. 1. Forest fires, when a tree that burns emits all of the CO2 that it has captured over the last centuries in only a few minutes. This means more CO2 conditions where forest fires are more likely. 2. The weakening of the thermohaline circulation. The melting of Greenland brings fresh water to the oceans. This could disrupt the water cycle even more and reduce the ocean's capacity to absorb more carbon and heat. And remember just how much we're relying on the oceans as a climate buffer. And 3. Melting permafrost, which means permanently frozen ground. It's releasing the previously trapped CO2 and methane into the atmosphere, and so adding to that additional greenhouse effect, which will then in turn lead to more ice melt. And of course, these feedback loops are interconnected. Current estimates suggest if the temperature increases by more than 2 degrees Celsius, an objective set by the Paris Accord, these positive feedback loops could set off a domino effect or tipping points that could become very difficult to come back from. This is a scenario we really want to avoid. This is a lot of information in front of us, and it's a lot to take in. You can see why it's urgent that we need to act, but it's also important we acknowledge how this is making us feel.